Hello dear amateur radio and space enthusiasts. I have good news. WREN passed the shaker test, and this video will show you how the test was performed in the facility of the University of Applied Science of Space Technology in Aachen.
So today is the day we're gonna make the shaker test, and let me introduce you to Mr. Pleasure. He's gonna supervise the shaker test and also perform the test, because actually we are not allowed to do it. So, Mr. Pleasure, can you explain us what exactly is a shaker test?
The shaker test is necessary to verify that the satellite will live the rocket launch and also the way up to the orbit. So you have strong acceleration during this time, and you have to ensure that the satellite will also withstand. What we have here is the necessary diagram or the necessary profile we have to do to qualify the satellite along with the launcher, which is a Soviet launcher, and they have gave us standard parameters which have to be tested, and the deviation from the standard parameters which you see here are the results from our test.
Okay, then I hope WREN gonna pass the test, gonna survive, and I don't want to see some conflicts later on. So here we're gonna fix the base plate.
So this base plate is actually the socle where after all our shaker box will be placed on.
So.
Und einmal lächeln für die Kamera, yeah!
The accelerometer sensor is now prepared for being placed into the shaker box, because with that sensor the response of the satellite during the shaking test will be measured and recorded. For that purpose, the accelerometer will be fixed with some wax inside the box so that it cannot detach itself during the test. Another accelerometer is placed inside this base plate in order to verify the applied shaking profile. Mr. Pleasure now mounts the WREN shaker box on the base plate of the shaker. The WREN shaker box base plate and the shaker box have been designed in a way that WREN can be shaked in any direction without moving the base plate. This is very important because the WREN shaker box needs to be screwed very firmly on that base plate, and so the introduction of errors can be reduced to a minimum.
And now we're gonna put this little baby in our box, and hopefully it will survive the test.
Our satellite WREN is now clamped between the support rails of the shaker box, like it will be fixed into the Emerford orbital injector during the launch. So the satellite is just inserted one time in the box, and then the complete box is then oriented in every direction that has to be tested. As the vibration that occurs during launch can be up to 6 times the Earth's acceleration, the satellite has to be fixed accordingly. According to the rocket's user manual, in the first place, a resonance scan test has to be applied in every axis of the satellite. So the test begins with a slow vibration rate of 2 Hz and goes up to 200 Hz. After then, a random test will be applied where you will have vibrations up to 2000 Hz. Finally, the vibration profile of a complete DNEPR rocket launch will be applied in every axis. This test will last for 13 minutes. The applied vibration profile and the vibration response of the satellite inside the box will be recorded and checked and counter-checked. For the evaluation, the data will be placed into the time domain, but also a power density spectrum will be used for the evaluation. If after that test WREN is still fully functional and the outcome of the test results are within the required specification of the rocket user manual, the test will be declared as valid and WREN is still go for launch. As you can see, the resonance scan test begins at a minimum of 2 Hz but will end at 200 Hz. On the screen you see the applied resonance scan profile and the response data that are recorded in real time. As the vibration rate is increasing, the box seems more and more to stand still. But in fact the box is still vibrating, but the camera, which only takes 24 pictures per second, cannot perceive the vibration anymore. The high vibration that occur during the rocket's flight have up to 2000 Hz. As mentioned before, the camera just can't perceive anymore these high kind of vibrations, but in fact you can hear the vibration. And this is logic, because the sound of the rocket during the launch is partially caused because of the vibration of the whole rocket. After the first X of the satellite has been tested to its full extent, the whole procedure will be repeated 2 times. Mr. Pleasure takes some pictures of the test object and will hand out us the certificate if we will have passed the test. After the shaker test has been completed, our satellite has been extracted from its shaker box and a functional test has been performed. Besides all the recorded data, the functional test is quite simple. It has a binary outcome. The satellite work or don't work. It's alive or it's dead. The mission is go or no go. I hope we are still go for launch.
The moment of truth. Yeah. It's working. It's working. Jetzt atmet nochmal, damit man es hört. Okay.
We are go for Dombarovsky.